For this experiment, we are going to be working with two general classes of synthetic polymers, addition polymers and condensation polymers. In part 1 of this experiment, we will be synthesizing nylon, which is our example of a condensation polymer. Start by gathering 10 milliliters of 5% adipial chloride, 10 milliliters of hexane diamine, and enough for 10 drops of 20% sodium hydroxide solution. Add 10 drops of sodium hydroxide to the beaker containing the hexane diamine and stir them together. Carefully add the adipial chloride to the solution by tilting the beaker and slowly running it down the side. Two layers will instantly be evident and a polymer film will form between the two liquids. This is the nylon. Using a copper wire hook, hook the nylon at the center and slowly raise it out of the liquid so it creates a continuous rope. Use something to wrap the rope around, like a graduated cylinder or test tube, and slowly roll the nylon from the solution. Once you are done pulling it, rinse the nylon repeatedly with water, then place it on a paper towel to dry. It is okay if some of the rope breaks in the process. You only need long enough chunks so you can make observations about the polymer. Now make observations about the nylon. Notice the strength, elasticity, and malleability of the ropes. Take the remaining reactants under the waste hood and stir vigorously to form additional polymers. Decant the solution into the halogenated waste container, and if any solid nylon forms, put that in the solid waste container. Once you're done with your observations, place the nylon in the solid waste container as well, not the trash. For the second part of this experiment, we will be forming polyvinyl alcohol, or PVA, slime. PVA is an addition polymer, and borax serves to cross-link the polymers. To start, gather 25 milliliters of water in two separate beakers, 1 gram of PVA and 1 gram of borax. Add each to the two separate beakers to make 4% solutions of both. The PVA solution will take significantly longer to dissolve, so you can speed it up by gently heating the solution and using a magnetic stir bar. The borax can be dissolved by constantly stirring. Once the PVA is completely dissolved, take it off the hot plate and allow it to cool to room temperature. If you want to add color to your slime, add a single drop of food coloring to the PVA before mixing the solutions together. You can mix colors together, but be aware adding more than one drop can result in darker, more concentrated color, like you see in the video. Once the solutions are room temperature, add 5 milliliters of the borax to the PVA solution and stir until your solution is no longer liquid. Place the beaker in the ice bath for a few minutes to allow your solution to thicken. Once you remove your beaker from the ice bath, remove the slime and knead it with your hands. This part of the experiment is best to do without gloves so you can feel the tactile properties of the slime. You will need to make 3 variations of the PVA slime. To do this, you will change one variable at a time while keeping the process and the other variables constant. For example, you can change the concentrations of either the PVA or borax solutions, or change the volume of the solution you mix by adding more or less borax. To remove any slime residue left in the beaker, clean the beakers with Alkanox soap and hot water. The solid slimes are not toxic, so you can dispose of them in the trash. Depending on your variations, your slime may be runny and not completely solid. If this is the case, add borax to the solution to further solidify it and throw it in the trash. Any remaining borax or PVA can be disposed of in the non-halogenated waste container. Thank you for watching. Remember to follow the necessary safety procedures and record thorough observations in your lab notebook as you go to help with your lab report.